Hello friends, happy day to all. Today we are going to see previous year NET exam question in data structure subject. Yes, let's begin. The first question is, what item is at the root after the following sequence of insertion into an empty split tree? That is, they are giving some set of numbers. So, what will be the value after inserting into a split tree? First of all, we should remember what is split tree. So, split tree is, the first point is, split tree is nothing but it is one kind of binary search tree. It is some set of, the next step of binary search tree. It is a BS tree. Okay, and whatever the recently added element will be placed in the root. Recently, just you remember these 2 points, you can easily generate the split tree. So, split tree is one kind of binary search tree. In this, recently accessed elements placed in the root, so that we can access that easily, right? So, this is the concept of split tree. Okay, so recently accessed element placed in the root, we can access that easily. For example, I will just explain with the simple values 1, 11 and 13. Okay, take only these values. 1 means, so the first I accessed this. So in a root 1 is placed and the next element is 11. Okay, so as per the split tree, what I told, the recently accessed element will be placed in the root. So 11 I placed in the root and 1 is compared with 11, it is a lesser than. So I am placed in the left side. And the next one is 3. So what is the rule for split tree? The recently accessed element must be placed in the root so that we can easily access that. Right? So I am next step, I am placing 3 here. And 1 is the lesser value of this and this 11 will be the coming under this side. Okay, just we have to do like this. So what happens, so what happens if they give 50 values also, no problem, just remember only the last value will be placed in the root, right? So no need to work out all these things, just think the split tree is the recently accessed element will be placed in the root. They are asking which item is at the root after the following sequence of insertion into an empty split tree. So, at the last element will be placed in the root. So, option B is the correct answer. Okay. With detail, I explained in the YouTube also, just check it out. The next question is, suppose we are implementing quadratic probing with a hash function hash y x mod 100 if an element with 4594 is inserted and the first 3 location attempted are already occupied. Then the next cell that will be tried is, they are telling us what is hashing. Hashing means I am doing some manipulation with the key. So here key is some data. So 4594 is the my x value. So this is x. So this value mod with 100. Mod means it will give the remainder. So when you divide this number divided by 100, what is the remainder? Remainder is 94. So in the 94th memory location, the value will be stored. Okay, in the 94th location, the value will be stored normally. But here this says that, and if I want to insert in that, but what happens? The first 3 location attempted or already occupied. Okay, here some values are occupied already. Some 54 or 65 and 66. So, what is saying this? The first 3, this is a 94th location and this is 95th location and 96th location. So, the first 3 location attempted. So, I am trying to attempt this location 94 which is already occupied by 54 and I am trying to next location. So, first 3 location attempted or 3 locations attempted or already occupied. Okay, consider this situation that 3 locations attempted or already occupied, then the next cell that will be tried is, then what is the next cell after 96? This is 97th location. So in this 97th location I am saving the 4594 value. Okay, so here it will be store what? The value is, data is 4594. Okay, but the address is, they are asking what is the next cell that will be tried is. So 97th cell. Okay, so from 94th is the address. So first 3 locations are occupied, so that I am storing in the 97th location. Okay, yes. The next question is, what operation is supported in constant time by the doubly linked list but not by the single linked list? Okay, what they are asking is, which is supported by the doubly linked list but not by the single linked list. So what is single linked list structure? So this is the single linked list, that is data part, and the another one is the pointer part, which is pointer which will be used to go to the next location of the node. Whereas doubly linked list is having 2 pointers. Okay, here you have only forward pointer, but using the doubly linked list we can go forward also. So this is the doubly linked list structure. Here you can store the data, and here it is a forward pointer, and this one is a backward pointer. So using this doubly linked list structure, I can traverse forward also and also through backward also. Using the doubly linked list, I can traverse either forward and also backward data structure. Right? Yes, this is doubly linked list, DLL, and this is singly linked list. So they are asking which is supported by doubly linked list but not by single linked list. The first one is advance. Advance means next location. So using doubly linked list also I can go next location, and single linked list also I can go to the advance, right? So this I can do it. Backup, and then first, you see, first location. If I want to first location data, using SLL also I can access. Using doubly linked list also I can access. And retrieve the element, that also accessible. But backward means what? So backward data. Okay, previous data. So that is not possible in single linked list, but it can do it in a doubly linked list. So they are asking what operations is supported in constant time by the doubly linked list but not, okay, which is not able to do it in a single linked list. So backup is done using doubly linked list. Backup, that is, we can go to the back node using doubly linked list but not by the single linked list. Yes, so option B is the correct answer. Okay, so once you draw this, it will be helpful for you. And the next one is, how much extra space is used by heap sort? So here they are asking how much extra space is used by. Normally heap sort is done with the it will be min heap and max heap. It is like BST search, and just it will, what happens, they are not used any extra space in a heap sort, not used extra memory space, not used extra memory space. They are just comparing the data and changing the data. Okay, so if it is an if it is 5 and this is 6, I'm just comparing, and then I'm just, if it is a max heap, I will change it to 6 here and 5 here. So no extra spaces are required for max heap or min heap. So they are telling that the extra space is not required in a heap sort. So it is a O of 1. The next one is, which of the following is not collision resolution technique? They are asking which is not collision resolution technique. So first of all, we have to know what is collision resolution technique. Collision resolution. So in an index, I am just saving in a memory location. So now it came now 94. So in a 94th location, if already occupied, if it is already occupied, what I am doing, I am checking the next location. If it is already occupied, I am checking the next location. So this kind of if already data is occupied means what? That is called collision. So to avoid this collision, what I am doing is linear probing and quadratic probing, that is hash addressing. And so which of the following is not collision resolution technique? Hash addressing is linear probing and quadratic probing. Okay, if the particular location is already occupied, what I am doing is, that is called collision. If a particular location is already occupied with another data, that is called a collision. To avoid that collision resolution technique is, one is linear probing. Linear probing means I am checking the next location. I am checking the next location whether it is free or not. So that is called linear probing. Quadratic probing means 1 plus n square. That is 1 plus, first it will search 1 and then search it is 4th element and then 9th element. So it will search in the quadratic space. First it will search the first location and then 4th location and then 9th location and then 16th location, like that. That is called quadratic probing. So this will come under hash addressing. So this is one type of collision resolution technique. And chaining. Chaining is another method. What happens? Whatever 94 is the whatever the data which is 94 coming, I am placed as a chain. Okay, for example 594. Okay, 594 mod 100. What happens? So this will also come under 94th location. If I give 694, so that will also come under 94th location. So what happened? I am doing as a chaining. Chaining method is, after this location I am placing here. So 94 reminder, those are the data which is coming 94 as a reminder, and place it as a chain. So 794. So this is also one type of collision resolution technique. So this is also so I am just shortly written as, okay, collision resolution technique. So hash addressing and chaining, these both are collision resolution technique. They are asking which is not collision resolution technique. Not. So not means both A and B. So this won't come. Okay, this is all, these both. So indexing is the correct answer. Okay, so indexing is a one type of method, that is you are find out in the address. So that is not the collision resolution technique. So indexing is not the collision resolution technique. Indexing is not collision resolution technique. Yes. The next question is, what is the time required to insert an element in a stack with linked implementation? Okay, whatever the stack is. So stack structure is what? This is the stack structure. So that is last in first out, LIFO. Okay, so my element will be placed here only. I am not going to traverse any of the list. Okay, so this is O of one location. In a stack, whatever, if you want to insert an element or if you want to delete an element, if you want to out. Okay, so if you want to insert, pushing and popping, both will take the time O of 1. Okay, so that is at the first time itself, at initially itself my job is done. I am not going to search overall all the list or anything. I am not going to do, because it is the topmost element. Okay, my operation is going to do in the top element, I mean top position. The next question is, in a balanced binary tree given below, how many nodes will become unbalanced when a node is inserted as a child of the node G? Okay, in a balanced binary tree. Okay, this is a balanced binary tree. How many nodes will become unbalanced when a node is inserted? When I am inserting a node, particularly you can consider this as an X. Okay, they are not telling the node G. They are telling when a node is inserted as a child node for G. Okay, that is I am inserting a particular node, some node, okay, X consider. If I am inserting a node as a child node of G, how many nodes will become unbalanced? How many nodes will become unbalanced? So what is the balanced factor formula? Right subtree minus left subtree. Okay, so to find out each and every node balance factor, we have to subtract the right subtree minus left subtree. So now you search, so for A, 1, 2, 3, 4, and after inserting a node, what? After inserting a node, X. So 1, 2, 3, 4 is a right subtree. Okay, so and then left, right is 2 and 4. So 4 minus 2, right, right subtree minus 2 minus 4, so this is minus 2, balance factor. Normally balance factor should be 0, minus 1 and 1. So this is balanced. So greater than this value will become unbalanced. So now you find out right subtree is nothing, 0 minus 1. So this is minus 1 and this is 1. Okay, this is 1, 2, 3. So 3 minus 1 minus 3, right subtree minus left subtree. Oh, so okay, 1 minus 3, that is here minus 2. C is 0 minus 2. This is also minus 2. This is 0. So this is okay, this is okay, and this is also 0 minus 0, 0. Okay, and here G is also this is 0, right subtree is 0 and 1, this is minus 1, balance factor. So how many nodes are unbalanced? The question is how many nodes are unbalanced? How many nodes are unbalanced? So which is not 0, minus 1 and 1, which is called as an unbalanced. So minus 2, this is one unbalanced node and this is also one unbalanced node, and this becomes unbalanced, and 0 is a balanced factor, and this is also 0 balanced, and minus 1 balanced, and this is also balanced, and this is also balanced. So how many nodes which are affected when I am inserting a node, when I am inserting as a child of a node G, how many nodes are affected as becomes unbalanced? That is A, B, C. This will become minus 2, that is 3 nodes are getting affected if I am adding a child node for G. Okay, so 3 nodes became unbalanced. Okay, how many nodes will become unbalanced when a node is inserted in a child of the node G? 3 nodes are unbalanced. The next question is, if the postfix form of a string is AB plus minus DST, the actual string is. So this kind of questions, first you can go to the innermost, okay, the innermost one. So here it is plus, right? So plus you take, so for every operand you need to, one operator need 2 operand, right? So this is a shortcut method, rather than you can also do from the option also, you can do, you can find out the postfix operation for this and you can see that equivalent, or you can go like this also. See A, B, C. So if you find this one, so BC minus will come here. So this is wrong. This will AB plus will come. So this is also wrong. A minus B, AB minus it will be. So this is also wrong. So BC plus. So if you do this parenthesis at first, see A minus B plus C, then star D. You take the answer and you can find out, and also from that also you can do it. For example, see BC, first I am doing BC plus. So this will become one part and this will become another part. Okay, so this is like A and this is like B. So A, BC plus minus. So this is became one part and this became another part. So this, like, you can just think like this part is now A. Okay, this part is now it is A and this one is B. A star B means AB star. So just write whatever the value inside A, B, C plus minus, okay, then D, then star. Okay, so this is one kind of equivalent on. So option A is the correct answer. And you can also do it like this. So you can split like this: BC, B plus C, and then A minus. So A minus, this minus will come here, right? And then star D. So you can manipulate like this also by seeing, and you can also from the answer you can bring the result. The next question is the algorithm that will efficiently sort an array that is nearly sorted except for the interchange of some adjacent pair of numbers like. So which algorithm will interchange the some adjacent pair? Adjacent pair means near 1, 3, so 2, 5, 4, 6. So this is an adjacent pair. So 1 for 1, 3 is the adjacent, and for 3 and 2 is the adjacent, right? So from like this I am seeing and interchanging the elements. So that is called, that will be a bubble sort. If I am doing like this, that is one type of bubble sort. So 1 and 3 I am comparing. Yes, 1 is lesser than and 3 is greater. So I am just leave it as it is. And then I am comparing, this is step 1, and step 2 I am comparing 3 and 2. So this is lesser and this is greater. So I am swapping. So 1, 2, 3. And then I am checking this element 5, 4. So and then 4, 5 will come. So and then 6 will be here. So I am leave as it is. So now in this step the elements are sorted. Elements are sorted. So if I am doing like this, that is for interchanging of some adjacent pairs, I am make it as an sorted array, then it is called as an bubble sort. Okay. The next question is T is a graph. Yes, the next question is let A and B be two arbitrary events. Then if A and B are two arbitrary events, then the formula is P of A union B is less than or equal to probability of A plus probability of B. For example, if you are tossing at 2 coins, so getting a probability of head is 1 by 2 and getting tail means 1 by 2. If you are union, if you want both, 1 by 2 plus 1 by 2 equal to 1. So this is the answer. Okay, so option C is the correct answer. And the next question is in what tree for every node the height of its left subtree and right subtree differed by at least 1. So consider this tree. So this one is right subtree is 1 and this is 2. So 1 minus 2 is 1. So always it may be right side or left side, but that is the difference between the right subtree and left subtree is differed by at least 1. So that is called as AVL tree. The next question is a hash function f defined as f of key equal to key mod 7. So this is the hash function with linear probing technique. It is used to insert a key 37, 38, 72, 48, 98, 11, 56 into a table indexed from 0 to 6. So what will be the location of 11? Okay, so I am first taking this key value 37 and mod 7. So what is the answer is 2. The remainder is 2. So this is the index. This is the memory location from 0 to 6. This is a table index. So 37 mod 7 equal to 2. So the 37 will be stored in the second location and 38 will be stored in the third location. And 72 mod 7 is 2. So if I already occupied, so now this is the second location is occupied here. So I am searching with the next location. Okay, because they are given the word that it is based on the linear probing technique. Linear probing technique means what? If the particular location is occupied, then I am searching the next element location whether it is free or not. So I am searching the next location for 72. So that is also occupied with 38. So then I am going to the next location and I am saved that 72 value in fourth location. Okay. And the next one is 48. So 48 mod 7 equal to 6. So 48 is stored in the 6th location. And 98 mod 7 equal to 0. So in the 0th location 98 is stored. And 11 mod 7. 11 mod 7 is 4. So but 4th location is already occupied. So I am, as per the linear probing technique, I am going to the 5th location and I am searching. The 5th location is vacant now. So the 11 is placed in the 5th location. You can also stop the process here itself, because the question is what will be the location of 11. So I found out the location of 11 is 5. And then for calculation purpose I am doing this 56. 56 mod 7 is 0. So 0 is already occupied, and so I am storing as in a first location. Okay, this is the structure, how it is storing as per the linear probing technique. The next question is, an embedded pointer provides. An embedded pointer is nothing. When you are referring a particular location, that location already having some address. Okay, I am referring 4000. Here you have an address. If I went to the 4000 address, this referring something 8000. Okay, so this is called as embedded pointer. Okay, that is secondary access path. This address again referring a particular address, and there I am going to get the value. Okay, an embedded pointer provides the secondary access path. The next question is, the initial configuration of a queue is A, B, C, D. A is at the front, so this is the queue configuration. Initial configuration is A, B, C and D. A is at the front. To get the configuration D, C, B, A, how many deletion and additions are required? So if I want D should be in the first place, what I have to do? I have to delete A, and then I have to delete B, and then delete the C. So 3 deletions are required. How many deletions? 3 deletions are required. So now I have to insert this C, B, A. So how many insertion I did? 3 insertion, right? So D is already in the place. I am not touching that. Okay. So 3 insertion, 3 deletion and 3 additions are required to get the configuration from A, B, C, D to D, C, B, A. The next question, which traversal technique lists the nodes of a binary search tree in ascending order? If you want an ascending order, okay, if you want an ascending order from the binary search tree, in which traversal you have to do it? In order, pre-order, post-order. Okay, this is an in-order traversal. That is one left, root, right. Okay, so you consider this tree. If I traverse in an in order, first I am writing 1 and then 5 and then 6 and then 10 and then 12. So and then 12. So you will get it in an ascending order. You will get the elements in an ascending order. So if you traverse the in an in order technique, you will get the ascending order elements. The next question is, which of the following is not collision resolution technique? So already seen hashing, addressing and chaining is collision resolution technique. They are asking which is not collision resolution. Not means indexing. Okay, indexing is not a collision resolution technique. It's just an addressing method. The next question is, for a complete graph with n vertices, the total number of spanning tree. The total number of spanning tree is given by n to the power, the formula is n to the power of n minus 2. Okay, so consider this is the tree, with 3 vertices. This is a graph. So how many spanning tree is possible from this tree? So spanning tree is what? It doesn't contain a cycle. So you are removing the cycle. So this is one kind of form, and this is one kind of spanning tree, and this is, you can rearrange in 3 ways, right? So 1, 2, 3, right? 1, 2, 3. So 2 and 3 way. So this graph you can represent 3 spanning trees. Okay, 3 vertices, 3 to the power of 3 minus 2. That is 3. Okay, so n to the power of n minus 2 possible spanning trees. in a complete graph with n vertices. Remember the word complete graph. Complete graph means all the vertices are connected with all the vertices. See here the 3 vertices are connected with all the other vertices. And the next question is, in a balanced binary tree given below, how many nodes will become unbalanced when a node is inserted as a child node? The same question here also asked. So when a node is inserted here, x, so how many nodes will be get affected, which is already calculated. So that is 3. Okay, have to identify the balance factor, right subtree minus left subtree. For each node you have to find out the balance factor, and whichever is balanced is 0, 1, minus 1 is balanced, and other values will be considered as unbalanced node. Okay. The next question is, pre-order is also known as depth first order. Pre-order is also known as depth first order. The next question is, which of the following statement is false? So every tree is a bifurcate graph. Yes. So tree is what? It is always 2 branches. Okay. So it will be, you can say it as bifurcate graph. A tree contains cycle? No. This is false. The question is, which of the following statement is false? So a tree never contains a cycle. A tree is, n means n minus 1 edges, and tree is also called as acyclic graph. Tree is called as acyclic graph. So a tree should not contain a cycle. So this is a false statement, and this is the answer. A tree with n nodes contains n minus 1 edge. This is also correct. A tree is a connected graph. A tree is a connected graph. The next question is, if the postfix form of a string is this, oh, this also already executed, I think so. Okay. So option A is the correct answer. The next question is, application of data structure queue is implementation of priority queues. So one type of application for the data structure queue is implementation of priority queue. Level wise printing of a tree is, it is nothing but a BFS, level by level. If you want to traverse a level by level, that is what breadth first search tree. It is the tree structure application. Okay, and then function call implementation will become under stack. Okay, depth first search in a graph. So that is also not a queue. Okay. So implementation of a priority queue is a application. The next question is, which algorithm has same average, worst case, best case time? So which algorithm has same average, worst case and best case time? Binary search. Normally binary search will be taken O log n time, right? So that's the same average, worst case and best case. They are telling that whatever the case it will take, all the average, worst case and best case time will be same. So in finding out maximum of n numbers, for example, you consider the list, so 1 to 10 elements. So 1 to 10 elements, if I want to get a 10th element, my average case is also, I have to search 10 list, and also in a worst case also I have to send 10, and best case also 10. So in this, to find out the maximum of n numbers, the average and worst case and best case, all the time complexity will be same. In quicksort it will be differ, and Fibonacci it will be differ. Binary search tree is an example of, binary search tree means what? Dividing and conquering technique. I am dividing into 2, and again I am dividing into 2, and again I am dividing into 2. So it is called as a divide and conquer technique. Divide and conquer technique. The next question is, what is the time required to insert an element in a stack with linked implementation? It is also already you have seen. So inserting means O of 1, because I am going to happen only in the topmost element. The next question is the equivalent postfix expression. So take this here you have a formula also, but in a shortcut method I will tell you. Okay, so wherever bracket is present, first you do that. Okay, just keep it as it is, and then first I am doing this E F plus. So once you are done, once this operation is done, you just make it as a bracket. Okay, you consider this will be the whole part X, and this is 1, and then now plus B star C. So here plus and here slash and B star C. So this has to done, right? B C star. Okay, make it as a bracket. Now you see 1, 2, 3 elements are there. Okay, A plus B means what? AB plus. So now you do plus slash at first. So division is the highest priority. So I am writing. So this consider as X and this you consider as Y. Okay. Understood? This you consider as X and this you consider as Y. So X slash Y, what do you write? XY slash, right? So similarly, you just write inside the element D, E, F plus as it is. Then write the slash. Okay, this is now it became X and plus B, C star. Okay, this will become one part and this will become another part. Just write as it is D, E, F plus slash B, C star, and this plus will be come here. Okay. So what is the answer here is C. D, E, F plus slash B, C star plus. Okay, this is the answer. The next question is, which one of the following is a physical data structure? There are two things. One is physical data structure and another one is logical data structure. Physical data structure means fixed. Okay, I'm not changed anything. Okay, so they are telling us array is a physical data structure where if you are defining A of 5, okay, so what happens? Just this 5 location is fixed. Okay, 5 location will be allocated to the array A. Okay, but in a linked list, tags and tables and all, we are changed, we are grow and shrink the size. Okay, so that is one kind of structure. Okay, so that will not come under physical data structure. So array is the physical data structure. The next one is, here the graph is missed, so just draw that graph. Depth on traverse or the following directed graph. Okay, this is the graph, you consider this, and so if you are traverse in a depth first search, so you've taken A and the next element is what? So we have to search here B, and then the arrow is here D, and then I'm moving to E. Okay, this is over, so I am taking this A, B, D, E, and the direction from E to the next one is F. Okay, so F is the next one, and from F it is C. So A, B, D, E, F, C is the answer. Okay, so this and this, then this, and then this, then this. The next question, the maximum number of nodes in a binary tree of depth 10 is, so that is 2 power 10 minus 1. So this is just formula for a binary tree of depth. So 2 power n minus 1. Here the depth will be considered as 10. Okay. So 2 power 10 minus 1 is the answer. The next one is, pre-order is also known as depth first order. The time required to find shortest path in a graph with n vertices and e edges is O of n square. The next question is, consider the following linked list. Okay, this is a linked list. So here you have a node, here you have a node, and this is a pointer Q. Which of the following piece of code will insert the node pointed to by Q? Okay, this is Q. I want to insert this Q to here. okay, to this location. At the end of this list, I want to insert this q to the end of the list. So for that, what I have to do? So for initially I am assigning list. So p equal to list. And what I have to do? I have to first move the pointer. This is p. So I am assigning list list to this pointer. I am moving this one by one until p of next. Okay, not p of null. P is not equal to null means this address will be I am checking, but I have to, because the last element will be null, right? So this pointer of next is not equal to null. I have to move it. This is a condition part. This is an initial part, and this is a condition part is p of next pointer is not equal to null. I have to move the list until the pointer of next is not equal to null. Okay, so this is a condition, and p equal to p of next, p equal to p of next. I have to increment every time to this node to this node and this node to this node. And after that, this p of next, this location equal to q address. This is 5000 you consider. Okay, this 5000 address will be present here. This p of next equal to q. This indicates that I am assigning the q address to this p of next. So that what happens? The connection will come here to the q. So option B is the correct answer. P equal to list, and p of next is not equal to null, and the increment part is p equal to p next. And after moving to the end of the list, what I am doing is I am assigning the pointer q to p of next. Yes? Yes. And the next question is, consider a rooted tree in which every node has at least 3 children. Okay, now consider a rooted tree in which every node has at least 3 children. Okay, this node has 3 children. What is the minimum number of nodes at level I of the tree? Okay, see, of the tree, assume that the root is at level 0. So the root is at level 0. So 3 of 5, this is 3 of 5. So when I consider 3 of 0 means 3 of 0 equal to 1. Okay, 3 of 1 equal to 3. So 3 elements will present. 3 of 2 is 9. So this contains 3 elements, and this level you have 3 elements. Okay, so in case of this formula, you just assign the value and see which will come under correctly. If it is 3i, it is not coming. If it is 3 power I, it is coming correctly, right? So consider root tree in which every node has at least 3 children. What is the minimum number of nodes at level I of the tree? So 3 power I. Which of the following data structure is used to implement recursion? So stack is used to implement the recursion. So whatever the value I present, I will take here, no? So stack is used to implement recursion. The next question, the height of a binary tree with n nodes in a worst case. So the height of a binary tree with n nodes, this is very careful. They are asking height of binary tree, not binary search tree. So the binary tree, it may be left skewed or right skewed. Okay, if it is a right skewed, you have to search n times. Okay, so if it is skewed tree, either by a left skewed tree or right skewed tree, the worst case is O of n. Okay, if it is a binary search tree, then it will be balanced. At that time, it is a log n. But the question is the height of a binary tree with n nodes in the worst case. Okay, so O of n is the answer. The next question is an example of a file extension. TXT is not a, TXT is the file extension. So PIC is not an file extension. MP3 is for an audio file. This is the extension, and web is not an file extension. Okay. The next question is, which of the following does not define a tree? A tree is a connected acyclic graph. Yes, it's a connected acyclic graph. Correct. A tree is a connected graph with n minus 1 edges and n is a number of vertices. Yes, connected graph, n minus 1 edges. Okay, that is, if there are n vertices, I have only n minus 1 edges. If it is 3 vertices, I have only 2 edges. Right? If you have n edges, then it will form the cycle. Right? A tree is a connected graph with n minus 1 edges where n is number of vertices. 3 vertices, I have only 2 edges. Then it is also called as a tree. Okay. So second statement also correct. A tree is an acyclic graph with n minus 1 edges where n is number of vertices in the graph, and this is also correct. A tree is a graph with no cycles. Here no cycle, but here they didn't say connected graph. Okay. In a pseudograph, graph means you have many forms, right? Always a tree should be mentioned as connected graph. So here this is the wrong definition. You have to always say that a tree is a connected graph with no cycles. No cycle is also called as an acyclic graph, but here the word is only connected. The next question is, which of the following is true for a sorted list with n elements? Yes. Insertion in a sorted linear linked list takes constant time. So whenever you are true for sorted list with n elements, sorted list for n elements normally taken constant time, that is O of n. If you want to insert n elements, it will take O of n. It will take some constant time. So O of log n will come under at the time of binary search tree. The next question is, files that are related to input, output and are used to model serial I/O devices such as terminals, printers and networks. So these are all called block special files. So this is just a theory, block special files. Files that are related to input, output and are used to model serial I/O devices such as terminals, printers and networks are called as block special files. The next question is, an example of a possible file attribute is. So possible file attribute, what are the file attributes? By defining the like read, write, append. So I am giving the permissions. Okay, giving the permission to a particular file, that is read permission or write permission or update, append. So many access, right? So these are all, this can be achieved by using R2 flag. So an example of a possible file attribute is R2 flag. Based on the R2 flag, I can identify whether that file can be able to read or write or able to append or something like that. So this is R2 flag. The next one is a total number of spanning trees that can be drawn using 5 labeled vertices. 5. Okay, so total number of spanning tree can be drawn using n to the power of n minus 2. Here n is number of vertices. N is number of vertices, right? So n is number of vertices. So 5 to the 5 minus 2, that is equal to 5 power 3, that is equal to 125. So the total number of spanning trees that can be drawn using 5 labeled vertices is 125. The next one is, in a heap, every element is dash of all the elements in a subtree. Actually, in a heap itself, maximum heap and min heap is there. Maximum heap means the root element is always greater than its child element, right? And then in a min heap, always minimum in a minimum, the root element is minimum than the child element, that is min heap. But if they ask just heap, so this will be indicate that is a max heap. This indicates that it is max heap. So in a max heap, every element is maximum of all the elements in a subtree. For example, so this is 5 and this is 6, this should be 12, and this is 5 means this should be less than whatever element, it should not be 1 or 2 like that. So whatever element it is, it should be less than 6. So less than 6, 3, 4, So the root element is greater than the root. Here 5 is the root for 1 and 2, right? So the root element is greater than its subtree. So this is its subtree, right? So this is called max heap. In a max heap, every element is maximum of all the elements in the subtree. The next question, if the rear equal to max size minus 1, rear equal to 0, else rear equal to rear plus 1 is required to. This is also look like circular Q, and it is also says that DQ. DQ means double-ended Q. DQ is double-ended Q. That is, I can add the element at the end or front. So on both the sides I can add the element. If rear is max, so here it is rear, I can move to this place at 0, and then I can add the element. So using DQ, we can add the element on both the sides, on double ended. Okay, so that's called DQ. The next question is, bitmaps are not often used in memory management. So that's a true. Searching a bitmap for a run of given length is slow operation. So if you are giving a running of given length, it will become, if you are giving a bitmap, then it will become a slow operation. So that's it. So both A and OR are true, and OR is the correct explanation of A. The next question is the complete graph. Remember the word, the complete graph with 4 vertices as k edges, where k is. So what is the formula for complete graph? Number of edges is n into n minus 1 divided by 2. So n is the number of vertices. Here n is 4. So 4 into 4 minus 1 divided by 2. So if you cancel 2 into 3, that is equal to 6. So option D is the correct answer. The next question is, which two of the following are equivalent for an undirected graph G? So consider it is an undirected graph G. Here in this 4 statement, which 2 statements are equivalent? G is a tree. There is at least one path between any 2 distinct vertices of G. G contains no cycles and has n minus 1 edges. Okay. See, if you take this option 1 and option 3, then it is equivalent. If it is a tree, means that the equivalent statement is G contains no cycle and it has n minus 1 edges. So option B, 1 and 3. The next question is, in a B tree of order m with p nodes, the average number of split is, just remember this is a formula, m by 2 minus 1. So Q is, stack is a LIFO data structure, Q is a FIFO data structure. What is FIFO? First in, first out. What are the elements added in a first, that will be removed first. First in, first out. That is, you see in a queue, so A came and B came and C came. So A came first, so A will be go out. So first in will be first out. The next question, in a full binary tree of height k, there are dash internal nodes. So in a full binary tree of height k, there are dash internal nodes. The formula is 2 power k minus 1. So you consider this is a full binary tree. So every node contains full 2 0 or 2 child. So that is called as a full binary tree, right? So here the height is 2. The internal nodes is 2 power 2 minus 1. Okay, so this is a leaf. So how many internal nodes are there here? So these are all internal nodes, right? So how many internal nodes? 2 power 2, 4 minus 1 equal to 3. So the formula is correct. 2 power k minus 1. The next question is, a binary tree is said to have heap property if all the elements along any path. If all the elements along any path have a heap property means what? Max heap. If they didn't specify anything, heap will be called as max heap. Max heap means what? The root will be greater element than its subtree. Okay, 4, 1, 2, something. So if first from leaf to root or non-increasing. If it is like non-node, you just change it as non-increasing means what? Decreasing. Okay, and leaf to root or decreasing. The first statement says that leaf to root or decreasing. So this is wrong. The second statement, from leaf to root or increasing. And third statement, from root to leaf or increasing. Okay, non-decreasing in the place non-decreasing means you can written as increasing. Leaf to root to leaf. Root to leaf or increasing? No. From root to leaf or non-increasing means decreasing. Okay, so this is the correct statement. From root to leaf, this is the 5 is the root. So from root to leaf or decreasing, the values will be always less than the root, less than its subtree. That's called as a max heap property. From leaf to root or it is increasing. So that is also wrong. We cannot say always. So here it may be 3. Okay, here it may be 3 and 1. So leaf and root may be increasing, or some elements will be differ here. So the exact statement is from root to leaf or decreasing. If the number of leaves in a strictly binary tree is an odd number, then what can you say with full conviction about total number of nodes in a tree? What is strictly binary tree? A node which has 0 or 2. Okay, for example, so this is one of a strictly binary tree, that is 0 or 2 child. Okay, 0 or 2 child. If any node consists of 0 or 2 child, then it is called as strictly binary tree. Consider this is a binary tree. See, in each node, this node consists of 2 child, this node consists of 0 child, and this node consists of 2 child. So this is an example of strictly binary tree. Okay, you consider this is a strictly binary tree. Then what can you see with full conviction about total number of nodes? See, what is the total number of nodes? 1, 2, 3, 4, 5. So number of nodes will be always an odd number. It is an odd number, it is an even number, it can't be equal to number of leaves. It is always greater twice the number of leaves. So no. So option A is the correct answer. Number of nodes in a tree is always an odd number. The next question is, the number of edges in a complete graph of n vertices is n into n minus 1 divided by 2. That is the complete graph. Number of edges in a complete graph. The next question is, at a hill station, the parking lot is one long drive way snacking up a hillside. Okay, so a car is going so car drives in a park right behind the car in front of them, one behind the other. So here cars are coming one behind the other. A car cannot leave until all the cars in front of its left. So if A is a car, B is a car, C, D. So if A left, then only B can left. If B left, then only C can left. And if C left, so if this kind of structure is the parking lot more like. So what kind of structure is this? This is nothing but a queue structure, first in, first out. So whatever the car came first, that will be removed first, right? So this will be similar to an queue data structure. The next question is, with regard to linked list, which of the following statement is false? An algorithm to search for an element in a single linked list requires 0 n operations in the worst case. An algorithm for deleting the first element, see, deleting the first element in a single linked list requires n operation. We already told that it is a first element. So at the time of first element, my time will be, complexity will be O of 1. That is, no, initially it will 10. So no need to search n operation and all. My time complexity is 1, O of 1. Within that O of 1 time means only what to say, one first time itself my job is completed. Okay, because it's a first element, right? No need to search all the n elements. So O of 1. So an algorithm for deleting the first element is always O of 1 only. Okay, if you know this one correctly, you just tick. So this is the false statement. But here in the second statement, this is that O of n operations in the first case. But always the first element, insertion of first element or insertion deletion of first element will be O of 1 only. But here it says O of n. So this they are asking which is the false statement. An algorithm for finding the maximum value in a circle linked list, O of n operation it will take. Or if you want to delete the middle node of a circle linked list. So in a circle linked list, if you want to delete a middle node, also it will take O of n operation. So this is also correct and this is also correct. They are asking which statement is false. The next question is, what is the most appropriate data structure to implement a priority queue? So implement the priority queue, heap. Heap is data structure is used. A chain hash table has an array of size 100. What is the maximum number of entries that can be placed in the table? So normally chaining means, I already told, no, hashing. If there is an element is collision, it will be stored as a chaining. So there is no upper limit. It will be go on, keep on adding all the data. If the remainder is 5, so all the remainder, the data which are giving remainder 5 will be stored in a chaining way. So there is no upper limit. This is measured for chaining.